had in the pictogram. And it is really amazing how she, after 2.5 years, really detected the right side for this formation here.
The mystery intensified when metal detector tests of the crop circles uncovered 3 unusual metal plates. Each plate contained an image of the crop circle pictograph, exactly the same design that had been carved on the wheat fields. German historian Moschkotti Litvas helped analyze these metal plates that were found to be made of precious metals, bronze, silver and gold.
I went with the plates with another man together to Berlin. There is an examination institute, a very, very big institute, and they found there is only silver in the silver plate, and the bronze is very unusual. We have never seen metallic plates like this. If you look on this picture, you see there are a lot of circles, but there are only 3 circles surrounded by half circles, and that are the places they found the 3 plates. In all the other circles, they found nothing.
How could such elaborate designs appear overnight in the darkness? Why did these huge symbols mirror the images of the metal plates? These are only 2 of the many questions that surround these mysterious circles.
From the deepest inner mind to the outer limits. Please stand by.
It's New York City. It's okay. March 7th.
Well, partly it's taken to these very strange images that are behind your head right now. These are pictures of equations. I've been, for the last 15 years, trying to answer the kinds of questions that my colleagues here have been raising. And what I've come to understand is that there are these incredible pictures that contain all the information of a set of equations that are related to string theory. And it's even more bizarre than that, because when you then try to understand these pictures, you find out that buried in them are computer codes, just like the type that you find in a browser when you go surf the web.
You're saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computers.
That is correct. So,
wait. I have to just be silent for a minute here. So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
Into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code. You're saying it is computer code.
It's not even just is computer code. It's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s. That's what we find very, very deeply inside the equations that occur in string theory and in general in systems that we say are supersymmetric. Some of those codes are showing on the screen behind you right now. They don't look like codes, but these pictures, which we call adinkras, are graphical representations of sets of equations that are based on codes. That in the description of our universe, that is a supersymmetrical universe, which we were going to test in the LHC. If you believe that description, I can show you the presence of these codes. That's my statement.
Do you have any predictions in your ideas, or any ways to test any of your ideas any more than, say, the guy over on the screen?
The work that I'm doing is, in fact, so theoretical that we don't understand yet whether it is even possible to complete the program. We have found these strange graphs. We know that they are equivalent to equations, and we have found in these equations computer codes. And so that's where we are right now. So I cannot give you a prediction. This work is less than 2 years old.
But it's not that you recognize that you will need a prediction in order to.
Someone recently asked me, said, well, you don't care about experiments, do you? And I said, no, that's exactly wrong, because you see, I have spent my career as a researcher worrying about supersymmetry. I would want to see an experiment before I shuffle off this mortal coil so that I know that I did not waste my entire...
This is towards Dr. Gates. Curious about your theory. You say there's computer code in these equations. Now, computer code is generally just instructions for a processor. And I'm curious as to what the instructions you're finding are. And if you're not sure what's to say that it's actually computer code, I mean, theoretically, the number pi has all the data that's ever existed.
Well, we say that they're computer codes.
I mean the digits in pi?
Yes.
Yes.
Okay. We say they're computer codes, first of all, because the structure of the equation is such that they dictate that there are certain things that are actually strings of ones and zeros. That's just digital data. But it's not just random ones and zeros. As I mentioned earlier, let me talk about something that you probably do every day, but I don't know if you're a computer scientist or not. Most of us sit at our...
Sounds that kind of fluency, I said.
Okay, well, most of us sit at our computer screens and we type on the keyboards, and we then send these, if we're using a browser, we're sending strings of ones and zeros elsewhere. But on the other hand, in the transmission process, there's always some fluctuations. So a zero that you type here because of static in line might be read as a 1 at the other end and vice versa. And so in fact, when you sit and type on the keyboard, your computer's doing something behind your back. Namely, it throws in a bunch of extra ones and zeros, and these things are called error correcting codes, so that the computer at the other end can look at the whole collection of what you typed plus what was sent and figure out if there were bits that were being flipped back and forth. And that's how you get accurate transmission of digital data. Among the codes that are used for this purpose are a special class of codes that are called block linear self-dual error correcting codes. They were first, in fact, the Shannon extended checksum code is an example of one of these things. These are the codes that we find buried in the equations. Not just any code, but these self-dual error correcting block codes. It's quite remarkable for anyone that I've talked to. We have no idea what these things are doing there.
Any literature out?
I'm sorry?
Do you have any literature out that...
I can give you technical references that almost nobody in the world can understand.
But Jim, I thought you had a popular level article on this?
Thank you. Yes, actually, so this past June, the British journal Physics World asked me to write a popular level description of what we have found. So in the June edition of Physics World, and it's published in London, the cover story is called Symbols of Power. It's about these weird symbols that have been showing behind us. We call these things adinkras. And so for a popular level description, yes, we've written that. But other than this one popular level description, it's all technical gobbledygook. Wonderful. And that's a technical term, by the way.
Gobbledygook.
Thank you.
There's a philosopher at Oxford, Nick Bostrom. The argument is called the simulation argument, and he argues that we are all very likely not living in a real universe, but living in a simulated universe. And we are being simulated on the hard drives of computers of the future. Now he gets there with a few simple steps. You simply have to acknowledge that consciousness is at bottom the result of information processing at the level of the brain, and there's nothing magical about brains. It could be information processing in a computer of the future. Most scientists think that's true. They don't think there's anything magical about the wet stuff in our heads, and that consciousness is at some point going to be instantiated in computers. Then you simply have to grant that humans of the future will run simulations of the past in the way that we run simulations, the Sims games, and then there's just one short move, that simulated universes, almost by definition, will outnumber real universes. And therefore we are a lot more likely to be among the simulated ancestors than the real ancestors. Now again, this everyone acknowledges it seems a little crazy, but the assumptions that you have to take on board are not so weak.